Okay, going to do a couple more elimination method problems. So I've rewritten the two equations out, so the simultaneous equations out, and labelled them number 1 and 2. Now, I can't highlight anything. Neither of the pronumerals has the same coefficient. So it's not as easy as the last example in the previous video, which was worked example 6. In the first equation here, it's 1x. In the second equation here, it's a 2x. In this equation, it's minus 5y. This equation, it's a plus 3y. So I can't highlight anything. But what I can do is I can look at these equations. If I get equation 1 and times everything in equation 1 by 2, my equation 1 becomes 2x minus 10y equals minus 34. I'll call that equation 3. So what I've done is times everything here, everything in that equation by 2. So that's equation 3. I now look at equation 2 and look at equation 3. They both have the coefficient of 2 with the x. Now let's remember, if that is the same sign, we subtract these equations from each other. And they do have the same sign. We're not looking at this sign here, we're looking at the sign with the 2. So don't get sucked in by this sign here and say, oh, those signs are different. It is the sign with the 2 that we're looking at, and it's both positive 2. So we subtract. So we go equation 2, subtract equation 3. So we have 2x, subtract 2x. It's gone. The x's are eliminated. We then have 3y subtract minus 10y, and we have 5 subtract minus 34. Alright, we had to subtract these equations because the signs were the same. So that becomes 3y plus 10y is equal to 39. 13y is equal to 39. Y is equal to 39 over 13. Therefore, y is equal to 3. Halfway there, we now substitute 3 instead of y in one of the original equations, either equation 1 or equation 2. I'm going to choose 2. Again, it just does have any minus, negatives, or whatever. That sometimes gets a little bit confusing for you. So substitute 3 for y in 2. So therefore, 2x plus 3 lots of y, and y is 3, equals 5. Therefore 2x plus 9 is equal to 5. Therefore 2x is equal to 5, take 9. 2x is equal to negative 4. Divide both sides by 2. So x equals negative 2. So our answer, therefore, is, so y is equal to 3 and x is equal to negative 2. So that there need to clearly show is our solution. Okay, one more worked example with the elimination method. There's equation 1, there's equation 2. Isn't immediately obvious what I can eliminate because the coefficient of the x and the coefficient of the y are not the same. This one's a bit harder than worked example 7. In worked example 7 we multiplied one of the equations by 2. In this case, it's not that simple. One way to get a hint to do it is if we multiply the first equation by 5. How did I know 5? I look at what's in the second equation. If I multiply the first equation by 5 and the second equation by 6, in other words, the second equation by what's up in the first equation, let's see what happens. The first equation becomes 30x plus 25y is equal to 15. The second equation, if we multiply it by 6, becomes 30x plus 24y equals 12. Rename those equations. Now look what we can do. The coefficient with the x is the same. They're both 30x and same sign, subtract. The sign with the 30 is the same. So we subtract these equations. 3 subtract 4. 30x take 30x, gone. No x, so we've eliminated the x. 25y take 24y is 1y. 15 take 12 is 3, so y is 3. Let's substitute y for 3 in one of the original equations. They both look similarly easy to me, so I'll just do it in number 1. So here's equation 1. And what we're going to do, where we see y, we're going to put 3, because we've just said y is 3. So 6x plus 15 is equal to 3. Take the 15 over to the other side. 6x is minus 12. Divide by 6. So x is minus 2. So my answer, y is 3. X is equal to minus 2. Again, let's clearly show that that is the solution.